Bismillahirrahmanirrahim. Assalamu alaikum and good morning to my students all over the world. As you know that we are up to this book and we are carrying this book out for our course, and we are at the fifth chapter. And fifth chapter is all about fractions and standard form. We have already done the fractional part of that uh, chapter, and now we are up to standard forms. And I have already told you about the standard form, scientific notations, exponential powers, and whatsoever is in this chapter. And in my last thumbnail, you must have noticed that there is a hint to convert from the uh, numbers to the standard form. How we have created the standard form from a simple number. So I am going to do that very thing on board today, and it is very easy to do it. So if you have, for example, now suppose we have an example that is 0.0005. Now we have to convert this format into the standard form. So how will we do it? It is very simple to convert it into the standard form. Now, since it is written 0.0005, now this is the decimal fraction. The common fraction, it was known as like this. You have already done these sort of fractions, but this is the decimal fraction. Now this fraction is written by one numerator and one denominator, and it is separated with a horizontal line. Now this uh, uh, is the format which is written in the decimal fraction. So it is written 0.0005. Now what will we do? We'll just either you have to like you just draw these waves over here, now how many waves are there? You see that 1 2 3 4 from first 0 to the 0 beyond the point is 1, and 0 after the point is also, and from first 0 towards second 0, and from second 0 towards third 0, and from third 0 to the end of the number. Now how many there are? Now this is, you see that 1 2 3 4 waves. These are 4 waves. So what will we write? We will write here 5 into 10 raised to power 5 into 10 raised to power minus 4. Or there is another method. There is another method to write this. We start from the point. You see, we start from the point. We'll consider this 1 2 3 4. Now it is very simple. 1 2 3 4. You see the result is same. Write 1 2 3 4. The result is same. It is just to let you understand the how it is to be calculated. Rather you can calculate it like this or like this. The result will remain the same. Now how this minus 4 has come over here? Why this minus 4 has come? How and why? Okay, let me elaborate this. Now we had 0.0005. So I have to remove the point from here. Now my dear students, you see that what we have is 0.0005. Now if I want to remove this point, I want to convert this decimal fraction into the common fraction. Now what I have to do is I have to place one underneath the point, and then all the zeros throughout the digits. All the zeros throughout the zeros. You see that there appear how many zeros have been appeared? Four zeros, or you can say that it has become 10,000. It has become 10,000. 10,000. Okay. Now this point has been moved. By moving this point, we have to withdraw these zeros also. We have to withdraw these zeros also, because the point has been removed and there is no use of the zeros uh, before the digit. Now what is the result? Now here is the result. Now 5 upon, if I convert this into the standard form, it will become 1 2 3 4 10 raised to power 4. 10 raised power 4. You see that something is going to happen over here now. Now if I shift this 10 raised to power 4 into the numerator, when the denominator is, if written like this, is shifted to the numerator, then we have to place minus sign like this. So you see that what it has come, 5 raised to power minus 4, which is already written as 5 raised to power minus 4. Now what I told you about, that we put the waves from from point, from the 0 before the point to the 0 after the point. This is first wave, and from first 0 after the point to the second 0 after the point, from second 0, or you can say it is head to tail arrangement. Just start from the 0 before the point and end up to the digit. So you see that it has become 1 wave, 2 wave, 3 wave and 4 wave. And if you count from the point, the whatsoever is in ahead of the point, then you see that this is, if this is was the point, then 1 2 3 4 digits, 1 2 3 4 digits, and place a minus sign over here like this, and your answer is there. Now I'll go straight to exercise 5.13, 5.13, which is very interesting exercise now. Now part A. Part A says that 0.04. Okay. Point. Now this is part A, 0.004. So just count from this side. 1 2 zeros are there. 1 2 zeros are there, and third is the digit. And if you see that 1 2 3, and if you draw waves from 0 before the point and 0 after the point, from 0 before the point to the 0 after the point, and from first 0 to second, and from, so how many waves are there? There are 3 waves. You see that in both the ways we have come up to 3 waves, or 3, number 3. We are concerned with this number 3. So it will be written as 4 into 10 raised to power minus 3. It will be written as 4 into 10 raised to power minus 3. So the rest of the questions are same in this uh, question number 1, but question number D, part number D, is little different from this thing, because it has many more digits ahead of the digits. Now this is written like this: 0.00. How many zeros are there? 7 zeros are there, I hope. 3, 4, 5, 6, 7 zeros, and 564 is written ahead of the zeros. 564 ahead of the zeros. It is very easy again. You see that what we will do. Now we can write it like this. If I apply this rule, I apply straight this rule. Now this is a straight rule. Now what will happen if I apply this rule? Now you see that there are 7 zeros. I know that I have written this. These are the 7 zeros. Okay, these are the 7 zeros. Okay, now this is 8th digit, 9th digit, and 10th digit. 7, 8, and 9, 10. 7, 8, 9, 10. So it can be written like this: 564 into 10 raised to power minus 10. But you know that when this sort of thing appears to you, you don't write all the figures, all the digits like this, all the digit like this. You write like this. You like this. That will be 5.64 into 10 raised to power. Now you have to consider that what will appear over here. Now what will appear over here? By placing the point after first digit, by placing the point after the first digit, you have to withdraw two zeros. You have to withdraw two zeros from here, and it will become minus 8, because you have placed the point over here. You have placed the point over here. If I elaborate this question, then you will come to know that we uh, how we created, how we done from minus 10 to minus 8, how we done minus 10 minus 8. Now this is a very important thing that you must know. Now this was written like this. You see that this was written like this. So what happened? Suppose now this is written like this. Let me rub this thing that you must. Okay, now 0.0003456 and 564. So I have written same thing over here. Now I am going to elaborate how this 10 has been shifted to minus 8. Minus 10 has been shifted to minus 8. I am going to elaborate it. Now suppose we want to make this thing into the common fraction. This was the common fraction. Okay, now this is the example of common fraction. Now what we do here, we'll just place point over 1 under the point, and then zeros, 1 2 3 4 5 6 7 zeros, 8 zeros, 9 zeros, and 10 zeros. And by placing this thing, now you see that we have placed this thing. Now this whole zeros has been abolished. We have just removed the sign. Now it has become 564 divided by this figure, 10 zeros. A figure with 10 zeros. Okay, how much it is, I am not concerned with it. Now in simple writing, I can write it like this: 564 divided by 10 raised power 10. So this step has appeared now. This step has appeared that 564 raised under 10 raised power 10. 564 into 10 raised to power minus 10. If I just shift this 10, if I just shift this 10 to the numerator, then this part will appear. Now what about this part? Now what I have done is I have placed, I have to place point over here. I have to place point over here. Now dear students, you see that this part has been satisfied by this equation, this fraction. Okay. Now, if I don't remove all the points, now there are how many points? You see that this was, yes, here I removed the point. So if I just remove the point up till 5. If I remove the point up till 5, so what happened? So the number of zeros will be reduced to 8. The number of zeros will be reduced to 8 now. Now you see 1, 2, 3, 4, 5, 6, 7, 8. I have stopped the point over here. Now what will happen, that it will become, rather to write it like this, we'll write it like this, 5.64, that will be equal to 5.64 into, these are 8 zeros over here, 1, 2, 3, 4, 5, 6, 7 and 8. So these are 8 zeros over here. So it will become, simply it will become 5.64 in 10 raised to power minus 8. So this was very easy question, and see how we transformed it from raised to power 10 to raised to power minus 8. And if there are some digits after the zeros like 1, 2, 3, 4, 5, 6, then we have to use this format, that we will not use this format. We will not use this format because this is not acceptable. So what we do that we'll just place the point after the digits, and this sort of thing should appear on the board. Now in question number 2 we have to reverse the things. So what will we do here? Question number 2. Now it is written like this. See that this is written like this. Part A, 3.6 multiplied into 10 raised to power minus 4. What does it mean? Simple, that it is 3.6 divided by 10 raised to power 4. Or you can write it like this, 1, 2, 3, 4. And also this point has to be removed. So for this point I am going to write this 1 under the point and 0 after each digit. So it will become, instead of 4, these will become 5. And the point is also has been removed from here. Now just align the things. You see that 2 zeros has been consumed. How many zeros are there left? 1, 2, 3 zeros and then 1 point. Now this 1 stands for point. Now what will happen over here? That it will become 0 prior to the point. We write it prior to point. 0 is always written prior to point. So after the point there are how many zeros? 1, 2, 3 zeros. 1, 2, 3 zeros, and then the number whatsoever it is. This is now 36. Now this is the ordinary form. We have changed, you see. And now if I want to vice versa, so you see that 1, 2, 3 and 4. 1, 2, 3 and 4, and here we have placed the point. So both the statement has gone true. So we will change from the standard form to ordinary form, and from ordinary form to standard form. And Now let me attempt question part number C. Now this is 2.03 into 10 raised to power minus 7. 10 raised to power minus 7. So simply what is this? This is just write these 7's 10 raised to power under this. This is 7. Okay. Now for these two also 10 raised to power 2. 10 raised to power 2. Now how many? Now you see that when bases are same, you have to add the powers. You have to add the powers. 7 plus 2 is equal to, now this will now this is the digit without any point. Now this is the 0 without any point, so it will become 9. Okay. Now from 9 3 of the zeros has been consumed. 3 of the zeros has been consumed. So we'll write this is like this. Always put a point, always put a 0 prior to point. So then point. And how many zeros are there? 6 zeros now, because 3 zeros has been consumed by this. So we'll write this 1 2 3 4 5 6, 1 2 3 4 5 6 and 203. Okay, now if you go, you see that 1 2 3 4 5 6 7, what it was written? 2.03 raised to power minus 7. So it is satisfied, it is correct. And if you want to go on the waves form, simple harmonic motion. Okay, so how many waves are there? 1 2 3 4 5 6 7. So the question was, yes, it was like this, into 10 raised to power minus 7. So we have already become come to 1 2 3 4 5 6 7. Okay, it is correct now. Now all other questions are similar, and so we I hope I just proceed to question number 3, and I'll be doing this question, half of this question in this session, and half of the 3 and 4 I will do in the next session. So let me start question number 3, because it is concerned with the simplification. Now question number 3. Question number 3 states that part A, simplify. Now when we say simplify, that it means that you have to you are cooping up with some operands that are division, multiplication, addition or subtraction. So first question A is about multiplication. So when multiplication is there, it is very easy. 2 multiplied by 10 raised to power, how much is it? Minus 4, and then multiplied by, then it is multiplied by what? 416. Okay, 4 multiplied by 10 raised to power minus 16. So what I told you, the format, just go for the multiplication. When there is a multiplication sign or division sign, go whatsoever is written. If it is multiplication, go for multiplication. If it is division, go for division, but don't go for addition or subtraction. State, because addition and subtraction will give you wrong answer if you go direct. Okay, now 2 multiplied by 4 is 8. Okay, 2 multiplied by 4 is 8, and when there are powers, with the same base, now the bases are the same, both bases are 10, then we will add these powers, and we are adding it below 0. So it is minus 4. See, it is minus 4 and minus 16, and from here it is minus 16. From here it is minus 16. For minus 16, this is 0. So how many? Minus 4, and what is the result over here? It is minus 20. So it is 10 raised to power minus 20. B is the same, C is same. Now part D. Part D, B and C are the same. Now part D states us that 11 minus 5. It is 11 10 raised to power minus 5, and multiplied by, it is 3 into 10 raised to power 3 into 10 raised to power 2. This is positive 2. Now you see that this is positive 2. This is negative 5. This is positive 2. So the procedure will remain the same. There is no change in the procedure. There will no change in the procedure. So what will happen over here? You see that 11 multiplied by 3 will go, because this is a multiplication sign over here. So we'll go for the straight multiplication. It will become 33. It will become 33. So, and adding these up, we'll 10 raised to power 2 minus 5 will give us minus 3. 2 minus 5 will give us minus 3. And if you do it on the number line, you will again get minus 3 over here. Now you see that this is not finished as yet. This is not finished as yet. I told you that this double number is not acceptable over here. This double number is not acceptable over here. So what we will do, we'll just withdraw 1 0 from here. We'll withdraw 1 0 from here. It will become, so it will become 3.3 into 10 raised to power minus 2. It will become 3.3 into 10 raised to power minus 2. How we have this? You see that this is 33, and which is divided by this one. Now I have to make it 2.13. So what we have done is we just removed 1 0 from here. By removing 1 0, what will happen? You see that this will become over here. So it will come over here. So it will be 3.3 into 10 raised to power minus 2. So my dear students, I think it's time to say you goodbye now, because it is very hot up here in my classroom, and the rest of the questions are related to division. So I told you that I will uh, I will solve half of the exercise today and half of the in next section. So it's time to say you goodbye. It's time to say you goodbye, and I'm going to sign up. Sign off. Like, subscribe, and share. Allah Hafiz.